Hi and a very good day to Professor Dr. Tehingwa. My name is Muhammad Azhar Aizat. Here are my group members, which are Hazim, Hakimi, Gan, and Justin. So today we are going to present our data mining project, which is prediction model based on SAS SEMMA methodology. So let us view some introduction to our project. Our project aims to leverage the SEMMA methodology to help user selecting the best laptop based on their preferences. So for our project, there are two models. Advanced machine learning model has been proposed, which is extreme gradient boosting regressor and light gradient boosting regressor. So throughout our project, we are going to modify the data and evaluate these models to choose which one is the best one to use as our prediction model. Our end product is the Streamlit web base, and our whole project will be conducted in a collab environment. Next, for our project objective, the first one is to select data using modern data sources. The second one to apply SEMMA, which is a data mining methodology in real-world application. And the third one, to develop a predictive model using advanced machine learning model. And lastly, to visualize the result using interactive figures to provide a more dynamic and engaging presentation.
Alright, for this is the SEMMA methodology. First, we go to the sample, and then we explore, then we modify, and then we modeling the uh, model, and then we assess, evaluate the model. Next, so for data set selection, we get the data from the table, which is brand laptop data set. They have 992 records of the different model across brands and specs. Next. Then this is our automated data handling using wide data profiling.
Next, we will proceed with our explore stage, which will be exploratory data analysis and the use of automated EDA using wide data profiling also. This is an example of a word cloud that have been generated that shows the model column and it shows zero missing value. Next slide. So these are also the analysis that we have found using automated EDA, which processor tier bar chart shows that Core i5 is the highest one in the dataset, followed by Core i7, Ryzen 5, Core i3, and other values. And this is the correlation heat map that have been also automated using wide data profiling. Another exploratory data analysis tool that we use are advanced visualization tool of PyPlot. This is an example of an interactive bar chart of brand distribution that shows Asus, HP, Lenovo, Dell, and MSI are one of the brands that are conquering this dataset. This is also the other analysis type that we have used, which is interactive histogram of price distribution in rupees and interactive box plot of price distribution. You can see there's a lot of outliers and the box plot of it on the right. Next. This is an example of interactive bar chart for processor brand distribution. And it's example of a pie chart on the right. So you can see Intel is the most used or is the one that is conquering this dataset. Another interactive bar chart example is processor tier distribution. This is just a bar chart example of the previous one that we have shown in wide data profiling. So this is our data pre-processing steps. First, we will check if there are any null values or duplicates. You can see there's none. And then we define the tier mapping for each of the cores or processor. For Core i3, we put it as an N3, mid, ultra high, and so on for different brands that we map them manually. Next, well, we will replace categorical values with numerical mappings also. As we have mapped before, we change them into 0, 1, 2, 3, and 4. And we also change if the secondary storage type is into no secondary storage, which is 0, to make it a negative word, negative. So this is our next part, which we call convert true and false to 1 and 0, and perform one hot encoding for the specified columns, which is brand, processor brand, GPU type, and OS. and we change no information to 0, as in year of warranty, and change to INT format. We divided the data into features and targets, which the target is price, and perform standard scalar to normalize the features.
I'm Gan and I will be explaining on the model stage. So the model that we have used for training will be the assemble methods, including XGBoost regressor and light GBM. So why do we choose for XGBoost and also light GBM? So we'll look at XGBoost first, because XGBoost is actually excelled in handling structured data or tabular data which having a high accuracy prediction. XGBoost could also handle missing values with irrelevant features and more efficient than other algorithms. It also includes regularization parameters to reduce overfitting when it works with high dimensional data. And then why we choose for light GBM is it scales effectively with datasets containing a high number of features. It also uses a lift while splitting algorithm instead of level-wise splitting, which can lead to a deeper and more optimal trees, which at the end it can improve for accuracy. Last will be include a built-in mechanism to handle class imbalance, improving performance on dataset. So this will be our XGBoost regressor, which will be also having our parameter grid to fine-tune our model, as well as having grid search CV with fivefold cross validation. The same thing also goes to the light GBM model. We will be having our parameter as well as grid search CV.
Hi everyone, I'm Justin. So now we'll continue to step 5, model evaluation or assess stage. So the models were assessed using two key metrics, the RMSE or the R-square score. So the RMSE, standing for root mean square error, measures the prediction error in the same units as the target variable, while R-square quantifies how much variance in the target is explained by the model. So the XGBoost regressor achieved an RMSE of 19,474.39 and an R-square score of 0.881, outperforming light GBM, which achieved an RMSE of 28,571.69 and an R-square score of 0.744. So these results clearly demonstrate that XGBoost provided more accurate predictions and better explained the variability in the data. So moving on, to interpret the model predictions, we utilize SHAP, or Shapley Additive Explanations. So SHAP summary plots were used to highlight the global feature importance across the dataset, and force plots visualize the contribution of individual features for specific predictions. So features such as processor tier, RAM, and storage capacity were found to have highest impact on predictions, offering critical insights into the model's decision-making process. So we also employed line or local interpretable model agnostic explanations to explain individual predictions. For instance, the contribution of the top 10 features to a single test sample's prediction was visualized, providing a clear understanding of how specific data points influence the output. So these are the results for SHAP. So based on the results, the XGBoost regressor emerged as the champion model. Its superior RMSE and R-square, coupled with robust interpretability through SHAP and line, demonstrated its strength in capturing data patterns in delivering precise predictions. While light GBM is known for its computational efficiency, its performance lacked in this scenario, likely due to dataset's characteristics and a limited hyperparameter grid. So in conclusion, XGBoost proved to be the optimal choice for this task, excelling in both predictive accuracy and interpretability. However, it's important to note that light GBM could be a strong alternative in scenarios with large datasets or when computational efficiency is a priority. So I'll pass on to the next presenter.
So here are some visualization and representation for our project. Let's move on to our project demonstration. So this is our end product, which is using Streamlit to deploy a web-based product. So in the left sidebar, we have two navigation buttons, which is to home by default and to the laptop suggestion. So at the home page, we have the title over here, which is Welcome to Laptop Suggestion based on SEMMA, SAS methodology. And we have two foldable section here, which is project description. So let us view one by one. So in project description, we attach here some introduction to our project and also the slides to our project framework. And then we attach here some user guideline to guide user how to use our project. So let's proceed to the next navigation, which is laptop suggestion. So now, as Professor can see, we are now at laptop suggestion tab. So here, user will have chance to filter their own laptop based on their preference. So first, they have option to select their brands. Okay, we have Techno, HP, Acer, Apple, and many more. So let's first choose Apple product. Okay, user have chance to select the price range, or they can skip. And also the other option like processor, processor tier, RAM, primary storage, and GPU brand. So let's say we choose some processor from Apple, and then the tiers, there are option here M3. Okay, let's view what available models. So here are some models that available from Apple product and the tier that we have chosen just now. So over here, there is a predicted price against actual price. So as you can see here, some of the price is almost similar to the predicted price.
For the recommendation, first you can now select the best laptop based on their preference. User also can compare the actual price with the predicted price based on the preference chosen, and then they can compare the computer specs across various of models. So for the conclusion, first SEMMA framework was successfully implemented along this project. And second, by systematically exploring, modifying, modeling, and assessing the data, the project can identify the factors influencing user choices. Then, XGBoost regressor has been chosen for its ability to handle complex relationship within the dataset. So, we want to thank you to the Professor Dr. Teh Ying Hua for teach us data mining for this semester. That's all for us. Thank you.